Good afternoon. This is Kavipriya, Assistant Professor, EC Department. Today I am going to discuss about the topic signal generator. So what is a signal generator? Signal generator is a device that provides the electrical waveforms or signal. It typically generates a signal such as sine wave, square wave, triangular wave or even a more complex waveforms. These systems are mainly used for testing, signal tracing, debugging, troubleshooting and are also used for amplifier response adjustments. And next is the components of a signal generator. First block is a oscillator. The core of a signal generator is a oscillator. It generates the oscillating voltage. This voltage varies over the time to produce the desired waveform. And next one is a frequency controller. So users can adjust the frequency of a generated signal using this frequency controller. This is done by controlling the oscillator frequency, determining how many cycles occurs per unit of time. Third one is the amplitude control. The amplitude or strength of a signal or voltage can be adjusted with the help of this amplitude control. So this controls the height of the waveform. It indicates the magnitude of the electrical voltage. Fourth one is the waveform shaping. The generators can produce different types of waveforms by shaping the output of the oscillator. For example, a square wave alternates between a high and low voltage levels, while a sine wave follows a smooth oscillation. And next block is a modulation block. Some signal generators offer a modulation capabilities also. Modulation involves varying one of the signal's properties. It can be a frequency, amplitude or phase to carry the information. This is common in applications like radio communication. And next is how does this generator works. So in the block diagram we have a block diagram, and in the block diagram the voltage control oscillator is a essential part because the input controlled voltage can be determined through the frequency of the voltage control circuit. So both the control voltage and the VCO frequencies are directly proportional. So once a signal is given to the control unit, it generates the oscillator frequency. Once a audio input signal is given to control voltage, then the frequency modulator signal will be produced using this VCO. The signal generator generates the tone, waveforms in digital pattern and arbitrary. Once a signal generates an unmodulated signal, then these are known for producing a continuous wave signals. So it generates a square wave modulated signal, complex and triangular waves. So this is a block diagram. It has a oscillator, it consists audio oscillator, voltage control oscillator, and it has a modulator, and we have this amplifier, and finally it will be given to the variable attenuator and output is being produced. And next is types of this signal generator. So function generator, the topic we have discussed previously, is a type of the signal generator. So function generator will be producing the waveforms like sine, square or triangular waves. It is used for testing and troubleshooting the electronic circuits. And next one is a arbitrary waveform generator. So it generates a complex waveforms with user defined shapes. It is ideal for custom signal generation in research and development. And next one is a pulse generator. So it is designed for generating the pulses commonly used in digital circuit for testing and communication applications. And next is the RF signal generator. It produces a radio frequency test signals for testing this RF circuits, and also it is used for testing the communication systems, and it is also used in the radar applications. And next fifth type of this signal generator is a audio signal generator. It generates the audio frequency signals. It is often used in audio equipment for testing and calibration. Sixth type is a digital pattern generator. It generates a digital pattern and sequences. It is crucial for testing the digital systems and circuits. And seventh type is a Sweep generator sweep through a range of frequencies. It is useful for frequency response analysis in filters and amplifiers. So each and every type of signal generator, it serves a specific purposes in electronic testing and design. And next is the applications of a signal generator. First one is the electronics testing. It is used for testing and prototyping the electronic circuits with the different signal types. Second one is used in communication. It ensures a proper functioning of a communication devices like radios and modems. Third application is the RF engineering. It designs and tests radio frequency systems and components. And next, fourth is a medical electronics. It develop and test a medical equipment including diagnostic instruments. Fifth one is the audio and acoustics. It calibrates and tests the audio equipment such as speakers and amplifiers. Sixth is the automotive electronics. It is used for testing the electronic systems in automobiles for reliability and performance. And it is used in aerospace and defense. It is essential for testing the radar systems, communication devices, and electronic warfare systems. And it is used in research and educations also. It is used in laboratories and education system settings for experiments and testing. It is used in power electronics. It is used for testing and designing the power supply systems, inverters and converters. It is used in environmental testing. It simulates the signals affecting the electronic systems for environmental testing. Signal generators are the versatile tools crucial for development, testing and maintenance in the electronic related fields. So that's all about the construction working principle and applications of the signal generator. Thank you.